Why do linear models hold such a pivotal role in machine learning? To answer this question, we delve into the world of linear models, exploring their importance and understanding how they operate. Linear models are often the starting point for many data science enthusiasts and professionals. They are straightforward, easy to understand, and yet incredibly powerful. Today we'll explore 3 popular linear models from Python's scikit-learn library: Ridge, linear regression, and Lasso. Firstly, we have the Ridge regression model. This model is essentially an extension of linear regression, a method that seeks to minimize the sum of the squared residuals. However, Ridge regression introduces a small but significant twist. It adds a penalty for complexity. This penalty, known as the L2 norm, discourages large coefficients, making the model more robust to multicollinearity. Imagine trying to juggle too many balls at once. The more balls you add, the harder it becomes to keep them all in the air. That's how ridge regression works. It tries to keep the coefficients, or balls in this analogy, as small as possible to prevent any one of them from becoming too dominant. Output. Next, we have the linear regression model. This model is the simplest form of a linear model, and it's used when there is a clear linear relationship between the input variables and the output variable. It tries to find a straight line that best fits the data points. Think of linear regression like trying to thread a needle. The thread is the line that the model is trying to find, and the eye of the needle is the smallest possible sum of the squared residuals. The goal is to get the thread through the eye of the needle as smoothly and as straightly as possible. Output. Finally, we have the Lasso regression model. Like Ridge, Lasso also adds a penalty for complexity to the linear regression. However, Lasso uses the L1 norm for the penalty, which can force some coefficients to be exactly 0. This feature makes Lasso a great tool for feature selection. Imagine you're at a buffet, but you can only choose a limited number of dishes. You'll likely pick the dishes you like the most and ignore the rest. That's essentially what Lasso does. It selects the most important features and discards the rest. In summary, each of these 3 models, Ridge, linear regression, and Lasso, brings something unique to the table. Ridge offers robustness against multicollinearity, linear regression provides simplicity and interpretability, and Lasso enables feature selection. Understanding the differences between these models and knowing when to use each one is a vital skill in the toolkit of any data scientist. As we've seen, linear models are powerful tools in machine learning. They are simple yet effective, and they form the backbone of many complex models and algorithms. So next time you're working on a machine learning project, remember to consider the humble linear model. It might just be the perfect tool for the job.